Okay, good morning. We wait till everyone is joining. Okay, so good morning. We will begin. So last time we talked about monotone convergence, right? So we see that if we have a sequence monotonically increasing and bounded above, then it will have a limit, right? And that limit is basically the supremum of the set of all members of the sequence. And then we see a corollary that when the sequence is monotonically decreasing and bounded below, then again the sequence will have a limit, and in that case the limit and the infimum of the set of all the members of the sequence are same. And so we see that and we see the proof. So we combine both of them and we can say that in one word, right? So this is the monotone convergence theorem. And so this is the monotone convergence theorem, right? So it says right, so it says the sequence is convergent if and only if it is monotone, right? So if a sequence is convergent, then it will be monotone, right? If the sequence is monotone, right? Sorry, I write it wrong. The sequence is convergence if and only if bounded. Right? If and only if right? So we prove two results. One is monotone increasing and bounded implies convergent. And then we prove monotone decreasing and boundedness implies convergent. So here we can combine both of them and say that convergence and boundedness are if and only goes under if and only if condition for a monotone sequence, right? So if it is monotone, then convergence implies boundedness and boundedness implies convergence, right? So here, so there is one part is already proved, right? And convergence implies boundedness, we prove, right? And then other part, you take two cases, right? right? So convergence implies boundedness. We prove, right? So that is, I think, according to the notes I posted, it will be theorem 2.2, right? So we prove that converges, right? So this part long time ago we proved, right? Convergence implies bounded. Maybe 1 week ago we proved it, right? Second part, right? To prove bounded implies convergence. Right, so if you want to prove bounded implies convergence, then this part already we proved in the previous class, right? If increasing, right, plus bounded, we prove convergent, right? So that will be case 1. The case 2 will be if decreasing plus bounded is convergent, that is also we prove, right? So basically the results of this theorem is a combination of 3 of our previous theorems, right? So this one, convergence implies bounded, we proved long time ago, right? Maybe a week ago or more. This one, bounded implies convergence, we proved 2 theorems. One is increasing and bounded convergence. Other one, corollary, we proved in the last class, right? Decreasing and bounded implies convergence. These two we proved in the last class, right? Tuesday class, and this one we proved long time ago. So that if you combine all of them, you get the monotone convergence theorem. Right. So as long as you know that a sequence is monotone, right? Whether it is decreasing or increasing, whatever it is, and as long as the sequence is bounded, it is guaranteed that the sequence will always converge. So if you want to verify a convergence of a given sequence, then this will be one extra thing you can verify. One is you can see the monotonicity in the sequence, and then you can see the boundedness in the sequence. And if monotonicity and boundedness holds, then you can say that the sequence is convergent. And so today, what we are going to do is we are going to do some examples where we will use this monotonicity and boundedness to verify the convergence of the result of the sequence. Yeah.
What could be? Oh,
Here is the first example. We are defining a sequence Okay, so let us define a sequence which is defined like this. So you start with y1 is equal to 1, right? Then y2 is 2 times y1 plus 3 over 4. Right? So then, so clearly, you know the sequence is 1, right? And then 2 times 1 plus 3 over 4, so 5 over 4, right? And then this is 2 times 5 over 4 plus 3 over 4, right? And then you continue like this. So the sequence will look like this. 1, 5 over 4. This is 10 plus 12. 22 over 16. And it will go like this, right? So you can write down the sequence according to this rule, right? Yn plus 1 is equal to 2yn plus 4. Sorry, plus 3 over 4. Right? So this is a sequence. So by writing the sequence, you can see